Hello, good morning. I am John Daniel M. Osmeña, and this is my Module 1 exam for ECEA lab. We are tasked with doing a positive clipper circuit that has a second voltage V2. So this is an example of the voltage that we are tasked to do. It has two voltage sources, two resistors, one diode, and spice directive. So in creating our schematic, we need to first create a new file schematic for it, and we need in inputting voltage sources. We just need to type volt. Then we need to input two V1 and V2 over here. Then we have one diode over, place it over here. Then two resistors, R1 and R2, R1 and R2, and we have to place the ground of the circuit. Then we have to connect it using wires, the wire tool. This pencil is the wire tool. So you connect it by this, by just going past through them. It automatically connects them. So over here. Now we input the value. So the value of our V1 is sine 0, 10. So that means it's at the peak to peak values, it's 10 volts and 100. So that means our voltage V1 has a voltage, it outputs the voltage of 20 volts. So let's just fix that. Then in our voltage V2, our value initially is 1. Let's fix this also. Then our diode is 1N914. That's our diode. And our both of our resistors is 1 kilo ohm each. 1 kilo ohm. And then we need to put labels or net names or net label nets okay, on the wires for voltage input and voltage output. So here is for the output. This is where we read the output. So if we are in a practical sense or in um, we have a tester in a circuit like this, we are going to check it here and here. So we put the probe here, and if we are checking for the input, we put a probe here. So this is our circuit, our initial circuit. So if we just remove this first, delete it now. So and run it. We have to put spice directive first, which is dot run, and it is 1M. And for 2 cycles, we are going to use the value of 20M for a maximum for the stop time, and 1M is the time step. So 20M means 20 milliseconds, our total runtime. If we run it now and check the voltage input and output, just change the color of this one. You can see this is our waveforms. So for voltage output, you can see here it's a positive clipper circuit. The the value in our positive half cycle is between 2 volts and 0 volts. And in our negative half cycle, the value is halved. So it's V in divided by 2 because of our R2 resistor in the circuit. That's why it's halved. So as you can see, it's 5 volts, negative 5 volts. And over here, it's 1.7 volts. The zero point 0.7 is because of the required voltage by the diode, and the 1 volt is because of the second voltage source V2, which outputs a 1 volt value, because in the positive half cycle, this V1 and V2 has to force or contest between the diode if it's going to be reverse bias or forward bias. So if the voltage of V2 is much more larger than the voltage of V1, the diode will go into reverse bias, opening the wire. It will be open, so no flow will go through it, therefore making the flow go over here and skip this wire and go over here. That's why we can read it in the voltage output. So if the voltage V2 is now much more less than the voltage being output by V1, then the diode will be forced into a forward bias, which makes it a closed wire. Then rather than passing through here, it passes through the diode over here and goes to the ground. That's why we can't read it here in the voltage output. So that's why we only have 1.7 volts here in the positive half cycle. So as you can see here at this part, over at this part, uh, as anything less than V2 is red because oh because the second voltage source forces it to become a reverse bias. So let's change it into I guess 3. You will see that from 1.7 it will become 3.7 because of the higher voltage being outputted by V2 as we run it again. As you can see here, see, it's as due to the higher voltage, the peak heightened into 3.7. See here, and if we due to the resistor R2, so that means all of our output voltages are half to, let's say, if we have 10 volts, 10 volts peak to peak like this one we have here, we have it so divided our our output peak to peak now is 5 volts to 5. So if we put the value of V2 to 5 volts, we can see, if we run it again, you can see now the voltage output is a complete sine wave. It is not clipped because the V2 forces the diode into a reverse bias, and due to the resistor 2, our peak to peak is limited to 5 volts. That way we can see the full sine wave. So if we revert, revert it back to 1, it is now again clipped. So that is all for my module 1 exam. Again, I am John Daniel M. Osmeña, and this is for the module 1 exam for ECEA lab.